As the Sino-Japanese War, essentially a full-scale conflict, dragged on from 1939, plans were made for a powerful freight locomotive to handle the increasing military transportation to the Kyushu region. However, it wasn't until after the outbreak of the Pacific War that these plans were realized, and the D52 was completed in 1943, when the war situation was already deteriorating. As domestic coastal ships were requisitioned for the war front and maritime transport became increasingly unreliable, the role of the railway ministry in material transportation became ever more crucial. However, the country faced severe material shortages, with metal resources being allocated primarily to the military, and the railway ministry had to manufacture vehicles that responded to this situation. As a result, the JNR was forced to manufacture rolling stock that could be produced with the limited resources available. These were known as wartime design vehicles, and the use of iron was avoided wherever possible, with wood being used as a substitute. The D52, designed to be a powerful locomotive, was no exception. Parts that did not require high strength, such as the deflector, deck, coal bunker on the tender, and sandboxes, were made of wood. The sandboxes, in particular, were said to look like makeshift huts, giving the locomotive a far from dashing appearance. On the other hand, in order to achieve its intended purpose, unusual materials for the time were used for the powertrain. The boiler installed was the largest of the railway ministry, with a steam pressure raised to 16 kilograms per square centimeter. Despite the worsening coal situation, it generated an output at wheel rim of 1420 horsepower, making it the most powerful of its time. Unlike the conventional D51, which was designed to be lightweight for use on secondary lines, the D52 was specifically designed for hauling heavy freight trains on main lines, with a heavier axle load to ensure adequate adhesion. To maximize the performance of the large boiler, the manual coaling operation was arduous. The firemen found that single-scoop shovels were insufficient to keep up with the coal demand, and double-scoop shovels had to be adopted. Due to the size of the boiler, there was little clearance inside tunnels, causing smoke to easily enter the cab. Additionally, the radiant heat from the large boiler directly hit the cab, making summer operations extremely difficult. Even in the face of air raids towards the end of the war, the D52s, through tireless efforts, managed to haul freight trains weighing up to 1,200 tons. Despite issues such as high coal consumption, the D52s managed to survive the war. After the war, when metal materials became more readily available, modifications were made to bring the locomotives closer to their original design. Automatic stokers were installed, and the improved quality of coal after the war led to better working conditions for the crew. The higher calorific value of post-war coal, which increased from around 5,500 kilocalories per kilogram to 6,700 kilocalories per kilogram, and the improved combustion efficiency due to reduced ash content, resulted in an increase in output beyond what could be expected from the increase in calorific value alone. Although the D52 was a wartime design, its frame and other undercarriage components were robust, and unlike the D51, which was prone to frame fractures, the D52 had few such failures. However, the high-pressure large boilers made with low-quality wartime materials had numerous issues. Eventually, a boiler explosion accident occurred at Yamashina on the Tokaido main line, leading to a complete replacement after 1955. Thus, the D52, with improvements to wartime design issues, played an active role on the major lines of Tokaido and Sanyo, supporting Japan's post-war economic growth. However, the rapid environmental changes after the war and the push for electrification of Japanese national railways, initially due to coal shortages, shifted the purpose towards increasing transportation capacity and improving passenger services, accelerating electrification. As the Tokaido main line became fully electrified and the Sanyo main line electrified to Hiroshima, the opportunities for the D52 to shine rapidly diminished. However, due to a shortage of locomotives, the D52 remained for a while to haul freight trains during the Hiroshima electrification. At that time, only 5 of the newest EF61 locomotives were deployed, and of those, 2 were used as helper locomotives for the 151 series Limited Express Tsubame and the 153 series Express Miyajima, as introduced in another video. Additionally, express trains of the time, which typically consisted of heavy 15-carriage formations of old-type passenger cars, had difficulties in cooperative operation with the EF58 and D52, leading to the decision not to use the EF58 for hauling. In contrast, the lightweight 20 series sleeping limited express trains could achieve a higher balancing speed at Senahachi, allowing the EF58 to climb with the D52 as a rear helper locomotive by removing resistance from the notch. The D52 excelled as a rear helper locomotive. Imagining such a train running today is enough to make one excited. However, the large amounts of soot emitted by the D52 fouled electrical equipment, such as insulators, causing insulation failures and becoming problematic. This rare sight of the D52 pushing a blue train disappeared with the introduction of the EF59, specially modified for helper service in this section. The D52's rapid decline in opportunities for activity, due to the heavy axle load caused by its high output, significantly impacted its future deployments. Excluding lines originally built for mainline use, such as the Gantoku Line and Gotemba Line, there were no lines where the D52 could enter as it was. Reassigning it to lower-class lines required substantial track reinforcement, and the high coal consumption on lines with low transportation demand was disliked by management. Furthermore, the inability to form long freight trains due to station length restrictions prevented the D52 from demonstrating its superiority over the D51. While some were converted to the D62 to allow entry into lower-class lines, the D62 had greater lateral pressure than the D51, necessitating speed restrictions and track reinforcement, and the coal consumption problem remained. After the war, there was a strong desire for powerful diesel locomotives capable of replacing the C62 and D52. However, the only available models relied on overseas technology for electric diesel locomotives, which were complex, expensive, and could not surpass the performance of the D52 using high-calorie coal. Later, the lightweight DD51, a versatile locomotive praised for both passenger and freight use, emerged with hydraulic drive and a 2,200 horsepower output, finally achieving parity with the D52.